So before I let you guys to, gather into groups, there are several things I want to talk about. The context of this problem, this is super important because from the feedback of last week, you guys like relevant examples. So I actually went out today to collect some data, real data. I guarantee this is real data. Okay, so let's take a look. And so it's probably not the most happy data we're gonna have because under the COVID-19 case, as you guys probably know. Okay, so what we have here is, what I did is I collected a bunch of death observation collected from New York City COVID-19 data as April 14. I also have more updated data from May 6 as of yesterday, but I didn't use that one because the data, the observation is much bigger. So I prefer a smaller size because, once you have a much bigger sample size, it will be very difficult for you guys to calculate. That's why I don't want you guys to work on that. Okay, so what do we have here are the other number of deaths in New York City. So this is very depressing. This data shows only the confirmed death, and I also cited a data source here because I want to let you guys know this is indeed a real data set. It's not a fake data set. Okay, so what I have here is I have 3 tables here. And later on, when you guys work on it, you don't have to work each one of them. You just have to sign up for one of those 3. You don't have to work on all of them. Just sign up for one of those 3. What I have here is I have a COVID-19 death in New York City. I classified the death according to age group. So there are 5 age groups here. And I also have another, underlying condition status variable. So the first one is underlying condition. So that means they do indeed have underlying condition. The conditions here are referred to, I don't have it here, but I have it in the Excel data form, which is also loaded on Canvas. You guys can download that data right to where you guys download this data as well. This worksheet. Okay, so let's take. Okay, so the underlying condition for this particular example refers to, I think it's just a heart disease, and so there's no underlying condition. That's the second variable. And the third variable here, not third variable, is the third status means we are not sure whether this person has an underlying condition or not. I also have a total count for this one. So the second one, the second data set here is regarding their gender. Female, male, or unknown. I also have underlying condition status here as well. And the last one is, I think this word means which district they came from, whether it's Brooklyn, Manhattan, or Queens, or Staten Island as well. So there are several underlying conditions here. Okay, what I want you guys to do is, so first thing is you do have to download this data. The data is the same place that you guys download this worksheet. And there are several tasks I want you guys to perform. I'm going to put you guys into breakout rooms a few minutes later. So you want to sign up your group first because clearly there are 3 data sets here. I don't want every group to work on the first one. I don't want all of you to work on the second one. So I want you guys to sign up. And I don't want more than 2 groups to work on the same one. And so it's important that you guys actually, have a quick chat and decide which one, but they are about the same. Okay, so what you want to do next is you want to carry out a test to determine whether there's any kind of relationship between your chosen demographic variable. So you might choose the gender, you might choose the district, you might choose the age group. So you want to see whether there's any kind of relationship between your chosen demographic variable versus the underlying condition status of the death. And then you're going to use the alpha to be 5% here. And if you do want to use Excel stat, I also recommend you guys to do that. So the comments are given here. If you did watch my video, the Excel stat video I did, you probably know how to do that. If not, you can use what I have here. And that's going to help you, hopefully helpful for you as well. And once you do that, you can use the following to present your results. Okay.
Are we only looking at
Yes.
Are we only looking at one specific row and one column, or are we considering the whole?
Okay, so first question I want you guys to think about it. So the first example I just did for today was comparing multiple population proportion. That's the first scenario you guys are going to work on for chi-square test. So what kind of a scenario is this? Are we comparing multiple population proportions here?
No.
We are testing to see whether there's any relationship between your chosen demographic variable versus the underlying condition. So this is a test of independence, right? I want to see whether there's any relationship. So this is a keyword you guys should all highlight, whether there's any relationship. So this is clearly a test of independence. So that means you have probably set up your table using this setup, right? Okay, you can use this setup to do it. You can decide which one, which topic, which demographic information you guys want to work on, right? One thing I want to check with you guys, I think I have two groups work on sex versus the underlying condition. So what is the conclusion I get from you guys? I think two groups actually work on this together. So I'm just going to use that one. I know one group also worked on age group. So what is the conclusion you guys get? What is, were you able to reject or fail to reject?
We rejected the null.
You rejected it, right? I think all, regardless of which demographic variables you work on, is all rejected. Okay, so were you able to, you rejected because the p-value is super small, right? It was very close to 0, right? It was all, okay. And rejected null, so it's super important that you write out a null and alternative right. So the null means there's no relationship. If there's no relationship, that means everything is the same. You know, there's no pattern regardless of which age group you are, or maybe which specific sex we're talking about. So I'm going to use the sex here. So gender and underlying condition, underlying condition are independent. And the null, sorry, alternative is going to be they are not independent. I'm just going to write down here, underlying condition are not independent. You can copy the Excel stat output here as well. You could also do the hand calculation. Try the hand calculation as well. And I'm just going to use one of the example I was going over in Hannah's group. I think it's a Hannah Ayuno's group as well, Canon as well. Okay, so if you do want to calculate this using hand calculation, it's going to be much more complicated. What I meant is, for example, okay, so what we have here is I have all of those numbers here, all those numbers. Observed frequency, your FO. I labeled them using black, FO. You can also calculate FE. FE has a formula we learned earlier today, which if you're not sure, you can go back to the first page. Okay, so let's see. So FE is row total, column total over grand total. So that's exactly what I'm going to do here. For this particular cell, the row total is 2530. I'm going to put it here. Multiply by its corresponding column total. You can add up those three numbers. That's going to give you 1551. That's right here. Over the grand total. That's right here. You do this. You calculate this ratio. It's going to give you 1905.27. That's going to be your FE. FOFE. You're going to do the same kind of calculation, row total multiply grand column total divided by grand total for every one of those, And then you're going to add up all those numbers. For this one, I'm looking at the 9 cells. So you're going to add up 9 numbers. So the first number is going to be 1873 minus the corresponding expected frequency. You square it. Divided by expected frequency. You're going to do the same thing for the second cell, that's 37, minus its corresponding expected frequency. You square it, you divide it by this corresponding expected frequency. It's going to be super tedious. And if you do use Excel stat, it's going to be much easier. And you can double check the degrees of freedom. For the sex, we have 3 groups here. 3 minus 1, that's 2. For underlying condition, we also have 3. 3 minus 1, that's 2. So that's a 2 multiplied by 2, that's 4. So you should double check to be sure your expected the degrees of freedom is 4, right? And so let's see. So we can go back here and write out here the test statistic. I think the degrees of freedom I'm working on is 4. And the p-value is 0. So you guys told me it should be rejected or null. And if we do reject it or null, there is a relationship or there is not a relationship between sex and underlying condition. So what do you think? There is a relationship or there isn't a relationship. You reject the null. So that means the null is not right. The null is not right. The alternative is right. So the sex and underlying condition are not independent, means there is a relationship, right? They are not independent, they are dependent. There's some kind of relationship. Okay, so there is a relationship between sex and underlying condition. Any questions from you guys?
Yeah,
Yes.
So when you were going over like the strong evidence to support the null or the strong evidence against the null, like when there's a big difference or little difference.
Yes. Yes.
I thought, so are those different for the two different tests? Because I thought that like since it was so close to 0, you failed to reject the null, but like this one was almost 0 and we did reject the null. So is it the opposite for each kind of test?
Good question, Sarah. This is an excellent question. Okay, so I want to emphasize here. Okay, so this scale, what do we have here? It represents test statistic, not a p-value. Not a p-value. Okay, so this is for test statistic. So for example, the example when we're doing, regardless which group you are working, you probably have a huge test statistic, maybe 30 something. If your test statistic is 30, that means it's right here. There's a lot of evidence against the null, even though it has a 0 p-value. But you don't want to use a 0 here because this is for test statistic, not for p-value. P-value talks about the corresponding area right here. Remember the area here. This is the p-value. If the test statistic is huge, that means you're going to be very far away here. The upper tail probability, the p-value is going to be super, super small. Does it answer your question, Sarah? Or maybe I didn't understand your question.
Yeah, because I thought that was the p-value was total, but I understand that.
Excellent. This is an excellent question you raised up. So this scale, what do we have here? This is for test statistic, not for p-value. P-value refers to this corner, this small number right here, this area. If you have a huge test statistic, say 32, for sex versus underlying condition, the p-value is going to be super, super small. That's a 0. You don't want to compare that 0 with a 0 test statistic here.
I had a question about my Excel stat.
Oh, yeah, sure. Okay.
It's giving me like a error message when I try to do the correlation test, saying that.
You mean the chi-square test?
Yeah.
Okay, maybe are you able to share a screen with me so I can take a look? So is this is a PC, right?
Yeah.
Great.
It's my
okay. So it has
laptop.
a slightly different interface from. This shouldn't be correlation. Could you go back to your Excel, start from very beginning, maybe close it so I can see how you got it. Close this one out. Just click, there's a cross on the very top. Yeah, let's try again. Correlation. Test the second, no, not the correlation. Okay, it's the third one.
Okay, this one?
Sorry, fourth. Test on contingency table. Yes, this one. That's what I meant.
Gotcha.
Okay, so let's choose the table. Okay, did you choose the totals column? You skipped the total column, right?
Yeah. Oh, okay. Yeah, I was just choosing the wrong test.
I see. And I think I probably went over the details with your group. You can click on the right arrow, the first icon. Yes, click on it. Great. When you go to options, the second, yes. Check chi-square and uncheck everything else because we are not dealing with, yes. And go to, sorry, hold on a second. Go to output. Okay, check contingency table and uncheck everything else.
Okay.
Great. Click OK. Great. And you can click on the gray lines, and so now it's going to work for you, right? You can see the chi-square test this, which is 32.847. The degrees of freedom is 4. The p-value is also given to you right away, right?
Okay. Yeah.
Okay. How do you like chi-square Excel stat so far? Have you used it? You used it for project, right?
Yeah. I think it's pretty cool. I can do some of the same stuff with my TI-84, but
oh, okay.
It's like I think if we already have the data in Excel, it's a lot easier to use.
Yes, you are absolutely right. So in order to use Excel stat, we do have to make sure the data is already loaded in Excel, right?
Yeah.
And did you watch some of the videos I made for our Excel stat? For example, randomly select rows. Did you watch those videos? Because I'm not sure. I see some of the students watch. I'm not sure who watch it. Are you able to? You did?
Yeah,
okay.
like usually when they're for during the projects, I look at the videos.
Yes.